Let's see how we configure SNMP v3. We've got a step-by-step configure your access list to constrain who can talk to your device, configure a view, which is a set of permissions, create a group, and that group is going to define how you communicate. Is it going to have data authenticity, data privacy? Assign users to those groups. How are you going to deal with events which are relayed via traps? And finally, interface index persistence, which is just about maintaining interface IDs numerically, not like the interface IDs that we see inside of the iOS, but interface IDs as in terms of how SNMP tracks those. We want those to be consistent to avoid disruption if the switch reboots. Let's take a look at SNMP configuration. Firstly, we have ACL 99. We'll reference that to control what IP addresses can speak via SNMP. And then we have our view. What is the view? Well, it's not just a Barbara Walters show. It's also a set of permissions for SNMP that allows us to control above and beyond read-write access. Read-write access is full access, but maybe we want to pare it down. Or maybe we want to pare down read access. So in this case, we can look at the uptime. We can modify the interface description. We could modify an interface's administrative status. What does that mean? What command does that enable us to do? Shutdown and no shutdown. And modify the operational status of an interface, so interface level commands. Then we craft the group. The group is named Z. It's a version 3 group. We are doing privacy. So privacy means encryption. The read view is ops. The write view is ops. So it's one view to rule them all. In the darkness, bind them. And then access 99. So we're essentially saying this group, controlled by these IP addresses, can do these things, but we don't have any users yet. The users are going to be married to device logins from the NMS level. User Z. I always think, why are we talking about zombies here? But user Z, group Z, basically says, I'm going to build this user that is a member of group Z. It's for v3 SNMP. Auth, SHA. So auth is talking about checks on each of the packets to ensure that it's coming from a trusted device and that it has not been tampered with. So integrity checks and data authenticity. It's a secret is the name of our key there. And then privacy is AES, really robust security, even to 256. So, that's a huge key. That's a very powerful encryption. And there's the secret for the data privacy, which is the encryption. We're going to do traps, and we're going to send them to the NMS at that location. It's going to be version 3, encrypted with the credentials of user Z. And the traps that we'll relay are about CPU and port security. And finally, interface persistence, because when our chassis reboot, there's the possibility of disruption of SNMP array indexes to the interfaces on the chassis. And so we save those to non-volatile RAM so we don't lose that information. And so there's a good walkthrough of a solid SNMP setup on our Catalyst switches.